Yeah.
Yes.
Okay, perfect. I'm starting. Hi, everyone. I'm Alaz, and today I'm going to talk about TaskFlow, my AI-driven project manager. Let's start with the problem statement. Inspired by agentic AIs in fields like environmental monitoring, this study investigates whether LLMs can act as hybrid project managers for software teams by comparing different LLM architectures in terms of clarity, goal relevance, and generation efficiency during sprint planning. Can these models meaningfully improve team coordination, planning, and adaptability? That is the question that we're asking. So, motivation. Traditional agile frameworks struggle to keep up with coordination, adaptability, and sprint efficiency in complex and distributed teams. LLM-based agents, as used in systems like Cognisim, can stimulate agile roles, automate task planning, and improve project flow. Let's take a look at the background. Modern agile teams are distributed and fast-moving, making coordination difficult. Manual sprint planning can be time-consuming and inconsistent. Let's take a look at what is an LLM. LLM is a large language model. It's basically a deep learning model trained on large data sets to understand and generate human-like text. An AI-powered project manager uses artificial intelligence to assist with software planning tasks like assigning responsibilities and generating responsibilities. So TaskFlow is an AI-powered project manager that uses LLMs to plan sprints, assign tasks, and simulate agile roles like a Scrum Master. So let's take a look at our related work section and start with these metrics. So readability score. It is not mentioned by the second, third, and fourth author, but the first and last author partially mention it, but they do not score it, they do not measure it. Goal relevance. Only the second author mentions semantic similarity, but there's no measuring. Other than that, the other authors have measured this. Sprint generation, the first author measures it. Second partially mentions it, but not measures it. Third one not measures it. And fourth and fifth, they mention, but they're not measuring it. And all of these references use LLM utilization in their projects. So user requirements, AI-powered sprint and task generation, real-time project and team management, interactive and responsive dashboard UI, and integration with external tools such as GitHub, AWS, and Vercel. So let's take a look at our approach real quick. So this slide illustrates the core decision-making and data processing flow in the TaskFlow system. So we start with the user input here, which is a prompt, which it can be something like, can you create me a 5-week development plan for an e-commerce application? It can be something like this. And this prompt is it is submitted through the front end. And this diagram shows how user input flows through different models. I have currently 3 different models. I will get into detail of it, but GPT-2 based, fine-tuned GPT-2, and fine-tuned FLAN T5. So let's talk about the models a little bit, and then I will go back to the approach. So GPT-2 Scratch, I trained everything from zero, including the tokenizer. It is the only fully custom model. Pre-trained GPT-2, I use the original GPT-2 model, just fine-tuned it with our project specific data. And the data that I created is the synthetic data. I create my own synthetic data and I train my models with that. The reason that I chose synthetic data is I wanted to that I could not find something that really applies to everything that I want. So I created the synthetic data using GPT, approximately 5,000 sprint tasks. Continuing the models, like I said, pre-trained GPT-2 and FLAN T5. This model was already trained to follow the instructions. I fine-tuned it using sprint planning prompts, and now user will decide which model they choose. You're going to see it in the demo too. But moving back to the approach diagram, so after generating the initial response, we send it to GPT-4 for cleanup in here. And so users selects one of the three models, and then the response is sent to the second layer. This layer is for refinement using OpenAI's GPT-4. So what does this layer do is basically it ensures the output is clean and it does not do any duplication. It is structurally consistent and it's formatted as JSON for downstream usage. And finally, the processed response is returned to the user via the front-end interface. So let's take a look at our deployment diagram. So this indicates and shows how task flow is deployed. The user interacts with the React frontend, which is hosted on Versal. Requests are sent to a Flask backend running on AWS EC2, where our local LLMs are hosted and executed. The backend also makes API calls to OpenAI's GPT-4 to refine or post-process the output before returning it to the user. And I want to mention one more thing before moving on from the deployment diagram, that why there is a WebSocket here. Since TaskFlow functions like a real-time AI chat, using WebSocket between the front-end and backend is more appropriate than using HTTP. WebSocket maintains an open connection, which is kind of ideal for continuous communication, unlike HTTP, which expects a really, really fast response, around 20 to 10 seconds, I think, which is way too fast for my for TaskFlow project. So I have selected WebSocket to use here. Let's take a look at our data collection. Let's start with the input data. Like I mentioned before, it could be something like, can you generate me an mobile application plan for, I don't know, 6 weeks. You can also say how many weeks you want to. It totally depends on the user. So with this prompt, the purpose of this is allows the user to describe a project goal, task, or workflow in natural language. It is used to generate task suggestions relevant to the prompt. And our output data, I have displayed our output data here. Just I took a snippet of it just to demonstrate to you. This is not how it looks in the UI. We're also going to see that in the demo too. So our output data is basically a task list structured, and it provides organized generated sprints based on the user's input, and it's displayed in UI for planning, reviewing, or sprint structuring, basically. Now our data analysis part. Let's start with the readability score. So we have 3 models, and in this chart, it demonstrates us that all of the 3 models scores. So as you can see, the highest readability score is in T5 with it's not even negative, but these 2 scored negative, Scratch GPT and pre-trained GPT. But in this case, I'm going to mention something that's really important. This for this metric, for Scratch GPT and pre-trained GPT, this score does not mean the outputs are really bad, they're not being able to read. It just needs more technical or compact language or knowledge of this, which lowered the readability score. Like I said, this is due to the fact that there's a structured formatting. I can move to the previous slides to show you that this is the task, this is the date, this is the priority, and this is the assignee with hashtags between them. So that is the reason why pre-trained GPT-2 and Scratch GPT scored really low in this metric. Moving on to the second metric, our task relevance to the goal. So this is one of the most important metrics in my opinion. This chart basically demonstrates how relevant each model's output was to the original task goal. So as you can see, pre-trained GPT-2 gave the most relevant results. It's approximately around 73%, more than 70. And this is the best one, task relevance to goal. As you can see, Scratch GPT comes a really close second. It's also more than 70%. It's somewhere around 71, 72, and pre-trained is 73, 74. So they're really, really close, but pre-trained outperforms it. And T5 has a really low score of, I don't know, 28% probably, approximately. It's between 20% and 30%. So moving on to our last metric, sprint generation time. So this chart basically demonstrates how long does it take for each model to generate a full sprint plan. As you can see, pre-trained GPT-2 and Scratch GPT-2 are really, it takes a lot of time for them to generate it compared to T5. T5 approximately does it around 1.5 seconds, and for Scratch GPT, it's around 9 seconds, and for pre-trained, it's a little bit more than 10 seconds. So pre-trained GPT is the slowest, and T5 is the fastest one. However, GPT-2 models were more relevant, and T5 is
minutes.
much faster.
You have
okay.
5
Okay.
minutes.
Okay, got it. Thank you. So related work revisited. So I wanted to demonstrate how task flow fits in these metrics after the data analysis part. So readability score, it's measured, flash readability score, goal relevance, semantic relevance is measured, and sprint generation, it's measured, and we also use 3 LLMs. So that's also utilized too. So our findings. So as you can see, let's talk about metrics one by one. T5 is much, much faster, approximately around 1.3 seconds. It is faster than both Scratch GPT-2 and GPT-2, making it ideal for real-time use despite the low relevance, as you can see. Readability score-wise, yes, T5 had the best readability, making its like output easier to understand, but because of the reasons I mentioned before, and I'm going to mention in the next slide, it doesn't mean pre-trained GPT-2 and Scratch GPT are unable to be read by users, you know, they're able to also read it. Moving on to the task relevance, again, Scratch GPT and pre-trained GPT like heavily outperformed. T5 fine-tuned and pre-trained GPT outperformed Scratch on relevance too. So our conclusion. So let's take a look at our problem statement again real quick. So we tested 3 models, T5, so we tested 3 models, T5, Scratch GPT-2, and GPT-2 pre-trained fine-tuned. So let's take a look at our problem statement, comparing different LLM architectures in terms of clarity, goal relevance, and generation efficiency during sprint planning. Can these models meaningfully improve team coordination, planning, and adaptability? These models can meaningfully improve team coordination, planning, and adaptability during sprint planning through clarity, goal relevance, and generation efficiency. So the 3 models, yes, T5 was much, much faster. The most critical, but the most critical metric for me was task relevance, since it directly impacts the sprint usefulness. So pre-trained GPT-2 consistently produced the most aligned and relevant outputs. The low readability score is a false negative. It looks bad on the paper, but the format is actually really clear and familiar to agile teams due to its technical conventions like hashtags and roles. And as you know, if somebody's going to use task flow, they're going to be a developer, so they are familiar with these technical terms. So that is, despite this trade-off, I still think, and I choose my preferred model is pre-trained GPT-2. It offered the best combination of relevance and usability, and it made my top choice because of this.
We can move to demo.
Okay.
There's less than 2 minutes.
Of course. That was my future work section. Security, user authentication system, and comprehensive testing will be added. I started the demo. This is my main UI, the AI assistant component. As you can see, I'm just fast forwarding the prompt writing here. User enters this prompt. I want to show you something here. So this is where the LLM is selected by the user, and the sprints are generated, as you can see in here. There is this in progress and completed section here too also. Moving on to the second LLM. We selected T5 here. Let me fast forward through the writing progress, and it's generated. As you can see, you can play with completed and in progress buttons here. Moving on to the third one. Again, I'm a little fast forwarding the writing part. Yes, as you can see, it's generated. And you can play with it. There's the priority I talked about, the assignee, the sprint, the date, and the task. And that is the end of the demo. These are my key references. Thank you so much for listening to me. Does anyone have any questions?
Thank you. Anyone of you have any questions?
If Shahid has any questions.
No, not right now.
So I just wanted to know, like you mentioned about a fine-tune model. So how did you
Yes.
train? Did you train that model, or like what mechanism you use to train the model?
Yes. So so let's talk about why I have chosen it. So for GPT-2, I custom trained the Scratch one. I custom trained it from zero using, I don't know, byte level BPP tokenizer and some lightweight configurations. For pre-trained GPT-2, I fine-tuned it with domain data for quicker conversions and better like generalization. And for T5, it was different from the other ones because it was instruction tuned. So model, yeah. So I like act on it through the prompts basically.
Okay, you use prompts to
Yes,
feed it. Okay,
yes. But for T5, the others, for them, it's different. But of course, the prompts were used, yes.
okay. Thank you.
Thank you so much. I'm stopping sharing.
Cool. So should I start?
Yep.
Let me know if the screen is
Yes.
visible.
It's good.
Yes, you can see.
Okay. It's not the presenter view, right? It's the just the slide.
It's the slide.
Yeah.
I don't see any presenter.
Awesome. Thank you. So, hi everyone. My name is Shahid, and today for my capstone, I'm presenting MediBuddy AI. That's a medical triage assistant. The purpose of this project is to improve initial symptom assessment using large language models and maintain clinical appropriateness and user trust. So the problem statement that we are trying to solve is how can we avoid delays and inefficiency in current traditional triage methods. Current methods are mostly reliant on manual assessment that has limited resources, and the decision making is quite inconsistent along with the bottleneck. Clinician and patient needs to understand and trust AI output. Uh, and our project basically tries to answer two questions. Those are, can AI triage replicate or surpass human reasoning in symptoms prioritization, and how can we ensure the system remain ethically sound and clinical reliable in real world use? The motivation stems from growing healthcare demand and inefficiency in triage processes. There's a clear need for a scalable intelligent solution that helps streamlining patient intake and prioritize care. Globally, healthcare systems are quite under increasing strain, and the volume of patients have been increasing. Something that we can clarify here is triage is a process of assigning urgency to a medical condition, and it's not directly a diagnosis. Background. So, since we discussed about differences between triage and diagnosis, one of them is we are just assigning urgency level and assigning it based on the data that we have received from the user. We can collect certain pointers about patient data like their age, pre-existing illness, gender, height, and weight. So historically, these triage methods have been used using a checklist kind of walkthrough where each hospital has their own kind of checklist that they go through and decide what should be the priority and urgency assigned to the patient. In our study, we analyzed the four studies over here, and what we found out from those is we are having a different methodology along with the purpose. Uh, Previous studies were either haven't specified their methodology or it relies on a single LLM or an AI. We are using hybrid reasoning with the conditional branching in case uh, uh, utilizing multiple LLMs and preserving the context. And previous studies didn't explicitly provide any output, and our study will provide an explanation urgency level along with the PDF summary output. To ensure safe and effective triage, users must provide accurate symptom data and consent to use those health information and able to understand the AI output. So some of the user requirement that we are following in our project is ability to use chat interface. Uh, Currently, it's a textual input providing. We are able to provide accurate and personalized assessment. Uh, Along with that, we understand the privacy and we take care of the consent, and we make sure the product has an ability to interpret and follow guidance. The diagram here is a use case diagram where a user or that is necessarily a patient is starting a web interface and interacting with an app using a text input. Uh, Behind the scene, there it's in the conversation is happening with Grok 3. Grok 3 is a conversational AI that's handling the initial input, carrying on conversation, and intaking various inputs before we call on the medical specialized LLM. Once the medical specialized LLM has all the context, we are providing an urgency score along with the PDF summary of all the relevant information that was collected at the time of conversation. We are storing this session as a session chat in DynamoDB and PDF summarization in AWS S3. So the user accesses the app using a browser. Here we are using Streamlit application that's providing a UI window that can work either on web or mobile UI. The outputs are stored as a PDF and also on the web. The chat interface that user is interacting into. The two nodes here are structured, that is symptoms assessment and the case study that's being done at Palmyra Med AI. System collects unstructured text input data from the user, can be in the form of a conversation, or it can be a one-shot text input where they have provided multiple data about themselves along with what they are going through. We are structuring those inputs using Grok 3, and this structure is further being provided to a specialized LLM. In future work, we also intend to provide a voice input where this conversation can happen in real time. For output, the current way of outputting is text, providing them the structured data from the context that has been received, and a PDF output that summarizes their important points and triage in a PDF format. In future work, we can provide it as a voice output. So some of the data analysis metrics that we evaluated were readability score and rogue metric. We achieved readability score of 40 to 60 that is fluent and much more appropriate for a healthcare professional along with general adult users. Since what we are intending is users 18 and above are to be using the application. Rogue metric is here that summarizes the matched clinical gold standards, how factual the coverage is, and are the right symptoms and recommendations being provided. We have coherence metrics. Within that, we have birth score that evaluates and references summaries. Our score 0.64 suggests decent logical structure and flow. A perplexity score indicates how predictable and fluent the language is. The lower score is better. Our score of 26 means it's a human-like fluency. Vader sentiment analyzes the emotional tone of the output. A score of zero point 0.5 was observed, which provides a neutral tone while providing an answer. So our project began with two critical questions. First, can AI replicate or surpass human judgment in triage? Our findings show that while AI might not yet replace, but it can reliably support current triage methods. LLM has an ability to summarize symptoms, assign urgency, and generate clinical relevant information. Second, how can we ensure AI triage tools remain ethical, integrity is maintained, and transparency is obtained? We approach this by keeping the system stateless. We aren't collecting any personal identification informations, and the whole chat conversation is stateless and anonymous. Additionally, all outputs that we are providing are stateless. We are referencing just a session ID that's being used for future interaction. In short, MediBuddy currently doesn't replace the clinician, but it meaningfully augments their reach and provide a scalable, safe, and interpretable triage for setting where fast and consistent care is essential.
You have 4 more minutes.
We thank you. We can start the demo. Is it breaking? Okay,
It is working.
it's okay.
Not anymore.
It's working now.
Yes, yes.
Okay, so yeah, I think it's some issue at my end, but here we are starting the interaction with the chats, and There are initial conversation that's happening using Grok 3 AI, which collects information from users and structure it in the initial phase. Further, it will use the structure, provide a summarization, and the summarization it provides to a medical specialized LLM, which assigns a which first summarizes the initial chat that was received, provides possible causes and an urgency rating. Whether an output in form of PDF is received that uh, it has a summary of previous interaction.
Oh, are you done?
No, has the video stopped? Actually, it's not visible on my end.
So we got the summary.
Oh, awesome. Moving to the next slide. So future work includes integrating a RAG using publicly available data like Mimic4 and use Pinecone for a deeper factual grounding. Currently, really limited data is available to check the current urgency level and test it against. One of them is Mimic 4 and its predecessor, Mimic 3. Adding a scheduling function can provide a user to connect with their healthcare provider in and also reduce the load on current healthcare systems. Since healthcare require compliances, hosting this solution in a HIPAA compliant infrastructure would be a next step. These are the sources and key references that I refer to. Some of them are based on ChatGPT based ED and LLM assisted triage.
Thanks, Shahid.
Thank you.
I think Veronica has some question.
I do, and it's multi-part, so I also put it in the chat because I know how being in the presenter, getting multi-part questions can be heavy-weighted.
Thanks for the question. Okay, so Grok 3 primarily is really efficient and cheap regarding before Gemini 2.5 Flash or models like that came along that can really handle well a conversation and the context and preserve the context in a conversation or a chat manner. Usually, when the chat application is decided, they are much less context aware with the API calls that happens, but Grok 3 had a better advantage when building a conversational manner. Second is NVIDIA Palmyra Med is one of the medical specialized LLM that in specialized medical LLM along with Google Uh, the other model like Google PubMed and BioGPT from Microsoft, those are not publicly available to use. There are certain uh, forms and like steps to go through to obtain that model, and it's only available for a research purpose, that too in quite limited manner. So
Okay.
Palmyra was good choice for similar functionality.
Okay. Thank you.
I missed the part. Like, is it free the model, or you have to pay the Palmyra?
Palmyra has free tier until like it's a credit based and initial uh, couple of queries are free. So uh, for building a demo or building the solution, they have good enough initial coverage that you can use for free.
Okay, thank you. I think we are done with this session. There were two presenters. Thank you both.
Thank you.
Thank you so much too. Thank you.